Usually, the number of sunspots vary in an 11-year cycle known as Schwabe cycle, which is better known as just solar cycle. We are currently in the solar cycle 25, meaning that it is the 25th solar cycle ever since scientific documentation of sunspot numbers was started in 1775. The periodicity of sunspot number was clearly identified by Samuel Henrik Schwabe after an initial observation for 17 years and later continued for another 23 years. But it was Rudolf Wolf who started numbering the solar cycles from 1775 based on observations of Schwabe and others. Amateur radio operators are very much concerned about sunspot numbers and solar cycles. There is an ongoing discussion on QRZ.com forum whether solar cycle 25 is better or worse than solar cycle 24. When the sunspot numbers decrease, ionospheric ionization on the Earth decreases, leading to poorer propagation on HF bands. I have personally experienced this long back in late 1980s when I started as an amateur radio operator. Initially, the propagation was good on 40 meter and later the propagation dropped while propagation improved on 80 meter. To take advantage of that, I added an 80 meter coil to my homebrew radio in those days and operated on 80 meter as well. When solar activity is high, higher bands like 10 meter are better, while 80 meter and 160 meter propagation improves when solar activity decreases, leading to lower ionization in the ionosphere. Now, coming back to the original question of whether there is a super solar cycle of solar cycles, which came up as a discussion on one of the QRZ.com forums, N2LKR, after observing the pattern of historical solar cycles, noted a sine wave pattern in the peaks of solar cycles. That raised a question of whether there is a super cycle of solar cycles. On posting this query on the HAM-SCI or Ham Radio Science Citizen Investigation Google group, K9LA came up with a detailed reply. He mentioned that while Schwabe cycle has a periodicity of 11 years, Hale cycle has a periodicity of around 22 years, during which Sun's magnetic field goes through its full cycle. The bigger Gliesberg cycle has a periodicity of approximately 90 years. K9LA also brought out a nice graph which showed the sine wave-like periodicity of maximum smooth sunspot number starting from solar cycle 1 to solar cycle 24. He also mentioned that it is possible to go back in history to get evidence of solar activity by checking carbon-14 deposition. K9LA further posted a graph showing carbon-14 data right from 8000 AD to 2000 AD. He explained that when the change in C14 is positive, Sun's magnetic field is weakest, corresponding to a solar minimum period, and lets in galactic cosmic rays that eventually deposit C14 into trees. When the change in C14 is negative, the Sun's magnetic field is strongest, corresponding to a solar maximum period, and keeps out galactic cosmic rays. He also mentioned that there appears to be a 205-year De Vries or Suez cycle and a 2300-year Hallstatt cycle. Truly mind-boggling types of solar cycles indeed. Now, what is the Monte cycle shown in the cover picture? It was a period of prolonged sunspot minimum around 1645 to 1715, when sunspots were very rare. Dalton minimum was another period of less marked decrease in sunspot numbers between 1790 and 1820. Increased sunspot activity starting in 1914 with solar cycle 15, peaking by solar cycle 19 in late 1950s and coming down with the peak of solar cycle 23 in 2000 has been called as the modern maximum. There is a lot more information on solar cycles for those interested in the Wikipedia article on solar cycle and linked articles.